We made it to the end of 3D Experience World. Hopefully everyone's had some good sessions this week. You found some information that can help out. We're going to talk a little bit about how companies are using Virtual Factory to improve their manufacturing operations and to get not just an understanding of layout, but also an understanding of actual operations. So what happens on the factory floor? So we're going to kind of just overall go through the whole process. So again, we made it through 3D Experience World. Hopefully you guys have found some good sessions, but let's go ahead. I'll just talk real quick about who I am, who Ellison Technologies is, just so you understand who's up here talking. I've been with Ellison for about 11 years. I've been one of our application engineers working with a variety of tools, but primarily SOLIDWORKS and the 3D Experience platform. Now, Ellison Technologies is essentially one of the largest machine distributors in North America. They brought on our team, GSC, about 4 or 5 years ago with the goal of essentially being able to teach all of the people who are using their machines the software side of things as well. So the most important thing here, though, is not me or even Ellison Technologies. It is SOLIDWORKS Virtual Factory. And what that means. What is a virtual factory? A while ago, I was out on site with a client of ours, and they had essentially 25 years prior installed a paint shop. And the day of installation, as the crews were there to basically stand this thing up, they discovered that there were some missed measurements or items that were not correct in their layouts. And then as well as that, up on the rafters, they had some AC units and some other things like that sticking down. They ended up having to push the walls out about 3 feet and move one of the doorways or entrances to this paint shop. Now, they thought that would be okay. I mean, obviously a huge cost that they didn't expect, because now they had to bring in extra wall panels, they had delays, they had a lot of other problems. But they thought it would be okay. Well, quickly after, they realized that that doorway that they had to move was going to be frequently trafficked. And since they just took 3 feet off of the corridor or the path there, they ended up basically having constant congestion and traffic in the facility, but they now have this gigantic paint shop that was basically immovable at this point, or something that they had kind of determined they were just going to deal with. Well, now this was 25 years ago, and the person who was giving me a tour and walking me around could not stop talking about how excited he was about their new paint shop. It's the one thing that stands out to me from that meeting is how many times he mentioned the paint shop. That's not what we were there to talk about, but he kept mentioning it, kept going back to it. And then a little bit later on, we were sitting down and we were kind of talking about this right here, this virtual factory. And he had made a comment that I think sums it up perfectly. It's so much easier to move pixels on a screen than metal out on the floor. That's the whole idea of what SOLIDWORKS manufacturing is all about. It's the idea of let's take the data that we're already working with inside of SOLIDWORKS. We've already invested the time into getting 3D CAD data, in getting 2D CAD data, in getting whatever format we have. Since we've already invested in that, let's take it to the next level and see what we can do with it. So here's the idea. Just a simple scenario we'll talk about a lot more, but in this particular scenario, we had a single 3-axis mill that came with this facility. We wanted to add in some additional machining capabilities. Now, in order to add those machines in, what wasn't shown in this is that that whole back wall is all office windows into the office space along the corners there. So they couldn't put the machines in the corners. The only real place they could do it was on the opposite side. Well, now they have workers split out between 2 cells for a very simple process. And then as well as that, what we have going on from there is essentially someone walking through a loading zone over and over again throughout the day a little bit more of a risk as well. Now, what they're considering is I can take this facility, I can take this cell, I can move it over to the other side, and then what happens from there? Am I going to be able to stay on top of part production? Are we going to be able to keep that going? Well, I can move a few things around, and then we can actually test out the scenario. So I can take it to that next level, and in this case, what we decided to do is check, if we put all three of those cells together, can we have one operator keep all three machines running and keep parts moving, and then maybe we can reassign that second operator that was working the one machine to something else, or maybe have them move around a little bit more during the day between different cells. As this simulation is running, the system is giving me data and measurements. How long did it take for a part to get from point A to point B? How much time did this machine spend waiting for a part? Potentially a worker to offload a part. All those different factors and variables, and everything's broken out into reports that we can then take and we can analyze. That is Virtual Factory. Let's take and test out the scenarios, test out the ideas that we have before we execute. I talk to a lot of companies about their factory layouts and new equipment purchases, all of those types of things. Ellison is a distributor of DN machines, DN Solutions machines. As a result of that, we get to talk to a lot of companies who are bringing in new equipment, ask them how they're doing it, ask them how it's working today. And one of the things that I hear really often is that we don't really bring in new equipment all that often. We try to avoid it because it just means we have to go through all of this. Or we'll hear things like, I've been trying to get a new machine like this in for years, but we just can't prove out the value. We can't show that it's actually going to be worth it for us. So that's where a tool like Virtual Factory comes into play. Now, Virtual Factory is broken out into two pieces. I've spent most of my time talking up here so far about Factory Sim, but the plant layout side of it is very important as well. So with Virtual Factory, there's kind of two main groupings or main goals that you might use a tool like this for. You might start out with the plant layout where you're essentially taking your data, fitting it into a simulation, not fitting it into a simulation, but just taking your data, fitting it into a layout. So this is going to be importing the layouts, creating 3D combinations. And then we have the Factory Sim side of it, which is where you start getting the actual metrics. That's where you add the logic, where you really start to take it to the next level. Now, SOLIDWORKS does a pretty good job, I think, in some cases of breaking things out into packages that are a little bit easier to talk about. So you have your SOLIDWORKS Standard, Pro, Premium. The same thing is true for SOLIDWORKS Virtual Factory. There's a Standard and there is a Pro. Now, the thing that I'll say is they make it nice and easy. For the most part, Virtual Factory Standard is all of the plant layout capability. Virtual Factory Pro is all of the simulation capability. So if you're looking at where that line might be, that's how you can kind of figure that out. But let's start by just talking about plant layout. What does the plant layout process look like? Well, first of all, we have to import CAD. And CAD can mean a lot of different things, and it's changing more and more. We're seeing new technologies, or maybe not necessarily new technologies, but old technologies being rejuvenated and used more by solutions like this to tackle challenges. So then we go ahead and we have to classify the resources. Now this part here is a little bit interesting. I put it in plant layout, but it's really only something you do if you're working on the simulation. It's part of the plant layout tools. You can do it in there, but it's a step you only really need to do during simulation. What this is we're telling the system this is a robot, this is a machine, and that will help the system understand what types of logic, what types of rules you want to apply to it for that simulation later on. And then we build the plant layout. So let's talk a little bit about Factory Sim and what's entailed in that process. Once you go through and you do your plant layout, you can define the flow. That's essentially, this piece of material is going to start out as a raw block of aluminum. It's then going to go to this station. Then it's going to get loaded into this machine. This machine's going to cut for 12 minutes, and out comes a finished part. Or maybe just a roughing operation one part that then goes to another station and gets machined further. You could track it through that entire process. Then we assign the resources. So now we've told it what is a machine, what is a robot, what is this or that. Now we can start assigning workers to different tasks. So we could say this worker is going to carry the parts from point A to point B. And we can actually see those workers walking around during the simulation. And then gathering the data. That's where I would say, as fun as it is to watch, as fun as it is to set these simulations up, this is the fun part and also where all the magic happens. We get to actually see this thing run. We get to see the factory do its thing and just observe. We used to do this by going out and standing on the shop floor and watching people work out on the shop floor and hoping that they weren't just working faster because I'm standing there over their shoulder or whatever else. Now we can track that data without any kind of bias or anything like that. So let's start by just kind of taking a look at the plant layout side and setting. We'll go through the actual setup process of a cell. All the stuff that you would typically expect to see in a 3D CAD tool for layout is here. We can snap components together. We can move things around. You could take any of your data and manipulate it in that way. So let's start with the import CAD documents. One of the biggest questions I get when talking to companies about this tool is, well, how long is it going to take me to get all of our data converted to 3D so I can use it in the system? And that's kind of the beauty of this tool. SOLIDWORKS Virtual Factory is not a SOLIDWORKS only tool. It can work with 2D CAD, 3D CAD, or point cloud. And I want to make sure it's clear that I said 3D CAD, not 3D SOLIDWORKS. It can work with a variety of CAD files from a variety of systems. So it's agnostic in that way. And really what that means is you can get whatever data you do have and you can start working with it. And another thing I'll say, as we'll get into this a little further, we'll see it, I've run simulations without any CAD data. I've had someone send me a Visio spreadsheet, or not spreadsheet, flowchart. And I've taken that and I've turned that into a simulation. Because essentially what I'm trying to do in many cases is just, how long does this task take, then this task, with all the branches and everything else? How do those different steps end up converging later on as the part moves through manufacturing? But let's talk a little bit about this one here, point cloud, because it is becoming increasingly common to use. The reason for that is it is the quickest and in many cases most accurate way of representing your factory floor. What it is a team will come out with these scanning backpacks, with these long extending scanning arms, and they scan the entire facility, and you get a point cloud, which is essentially just billions of points in 3D space. Really fun to watch how they come in and do all of this and how they scan every inch of the facility. Now, one of the things I mentioned earlier, the paint shop. Their major issue was an AC unit that wasn't in any of their 2D layouts because it's up there. When they created the 2D layouts, they were looking down here. It wasn't something that really came up, wasn't something they thought about, but that's one of the main reasons people are starting to take an interest in point clouds more and more, is they capture everything. You're gonna see that full verticality of everything. And then as well as that, it's a very detailed version of the model. So in some cases, the difference between being able to get a piece of equipment where it needs to go without moving a piece of equipment is the clearance that you have below the control system or the control unit on a machine. Things like that can really make a big difference. So this allows you to test all of that out. Now with point cloud data, it's not like typical CAD where you're just taking and moving bodies around. But what it is you draw like a, essentially a mesh shape, like a cube or cylinder or whatever over these points, and you can group them up, and you can even save that out as an asset now. So now that's something you could bring into other layouts and move around. And then you're able to just kind of move that around and get it exactly where you want it. You can test it within the whole layout. Now, one of the things that we're asked very often is, well, what if I don't want to pay to have my entire facility scanned, and I just want to work with maybe a section of it? You can scan a section of your facility and then work in a mixed CAD environment where you're able to bring in 2D data, like this forklift, and then once you do that, you can essentially start pulling in other 3D parts, like this conveyor, like this crate, and we can start to visualize all of that working together. So any CAD data I have, whatever I have, I can bring it in, I can put it together, and I can start to make magic happen and see exactly how the factory is going to work. Now, of course, one of the most important things is if I want to take it to that point later on and start doing those simulations, I obviously need real times. I need to understand how long does this task take? How are we transporting data, or not data, material from this station to this other station? I have to understand all of those things, but with that information, I can then start to take these layouts that we're building in plant layout and take them further in simulation. So in this case, I wanted to show, I think one of the most common workflows people use is they start with the 2D layout and then they put whatever 3D assets they have on top of it. So in this case, we're just importing a DXF, DWG file, just a generic 2D CAD file. And now that I did that, I can bring in whatever models I have. I'm just dragging them from my library and dropping them into space. And then we even have a snap tool that lets me basically pick a point on one and then a point on the other item, and I can snap those together for quick positioning. So rather than mates, where we might be typically picking faces of a model and tying all of that together, you could just work point to point, simple click and snap. Very quick way to lay out a lot of stuff. Now, as well as that, there's patterning commands. So I use that a little bit to get the other 3 tables. There's patterning commands, all the type of stuff you would typically expect. And then we just keep adding models. We keep moving things around, organizing it, and getting the exact layout that we need. And it doesn't necessarily have to stop there. Like I said, if we plan to take this to that factory simulation stage, we could start to identify and classify our resources. We have different resource types that Virtual Factory understands, and each of these controls the logic that we're allowed to use later in our factory flow. So we can tell it this is a conveyor, this is a robot. A manufacturing product is a piece of material that's going to move through the flow. That might be a raw chunk of aluminum, that might be a finished part, that might be paint, that might be glue, whatever the case is. A manufacturing product is something that is taken in as part of the manufacturing process. And then I can define workers, robots, storage, all of those types of things. So let's just kind of take a look at what that looks like when we have a cell. So I've brought in all of my CAD data. The workflow I like to use is I tend to bring in all of my CAD data, and then I add those items essentially as resources or as sub-items of resources. So in this case, I'm creating some basic organization level resources. An area called extras, that's where I put the fun decorative type stuff that I throw in here to make it look pretty when I show off my my proposal. And then I'm going to put in an area called fencing, and I'm just going to drop all the fencing in there so we can kind of create this sub-assembly type structure, just like we're used to inside of something like SOLIDWORKS. Now I can go ahead and I want to start creating the actual important resources, which are the machines, the storages, the different things like that. So I can go ahead and I can create an NC machine object, and now I just put my CAD underneath that. Now, something that's kind of cool from this is when we do get into that simulation state later on, the CAD is separate from the resource, which means we're applying the logic for the simulation to that NC machine object, not the CAD, which means if I decide later on, after I've already built out a simulation, we want to try a different piece of equipment, I can swap out that CAD. Or it also means I could set up that entire simulation without the CAD and add the CAD in later on. It's very flexible in how it works there. Then we have the plant layout itself, and we kind of already showed that a little bit with the importing of 2D data and then working off of that 2D data. Not a whole lot changes here, but I did just want to kind of show a little bit of a zoomed out view here to kind of indicate that we can work at multiple levels. So this particular cell is an entire plant, and then we have several sub-cells in here. So we have inspection, machining, assembly, and then outgoing shipping. All of that is represented here in one massive top-level assembly. Now, something else that's very important to point out. This is why SOLIDWORKS Virtual Factory exists. If you've tried doing factory layouts inside of SOLIDWORKS, you have probably at some time said less than the nicest words to your computer as it starts to slow down and chug along a little bit. And there's not a lot you can do about that. SOLIDWORKS just kind of has a limit with hardware. The hardware is the limiting factor in a lot of cases today. So with this here, you're still going to need a powerful computer. I'm not going to tell you that this runs better on the same hardware as SOLIDWORKS, but what it does do is it scales really well with hardware. So I have been able to run massive plant layouts within this tool. Everything rotates very smoothly. Everything zooms very smoothly. Working with this one here, it's smooth. And the preview applications that exist within the 3D Experience platform are built for the same type of data. This is all built on the technology that we typically see with the kind of higher needs tools like CATIA. Now, the plant layout side of it is pretty intuitive and straightforward, and I think it's something that for a lot of people it just kind of clicks. If you've used CAD or SOLIDWORKS before to move things around, the plant layout is kind of exactly what you would expect. But the simulation, in a lot of cases, this is kind of, I'd say, a very rapidly emerging process. It's something that's kind of newer. A lot of times when I talk to people, they don't know that you can do this type of thing, this type of simulation. So I like to spend a little bit more time talking about what this all is, what it looks like, how do you do it. So we're going to start out with just defining the flow, the simplest part of the whole process, which essentially we're going to take those resources that we defined before, so conveyors, manufacturing products, machines, workers, storage. We're going to take those and we're going to add activities. These activities are different things that happen out on the shop floor. Loaded a part into a machine, unloaded a part out from a machine, transformed a part. We took something in and we output something else. That could be, we took in a block of aluminum and we output a rough machined part. So we assign all the behaviors that we want, and SOLIDWORKS Virtual Factory makes this pretty straightforward. There's a define factory flow command, and with that define factory flow command, I can essentially start defining my whole process. I also have the capability to, on an individual basis, define equipment. So in this particular case, I put one of the zones we'll use on that piece of equipment, but I'd rather use the more automated flow for defining everything. So I start by clicking on the ground and creating an in zone. That says products come in here. Then I pick that product and then the bucket. That says parts come in and they spawn immediately into this bucket. Then we're going to send them to the inspection machine. Then they go to the pass bin. Then they go to the drawer that's going to be fed into the drawer system of the next cell, which I'll represent here as an out zone. Essentially, we're doing a self-contained simulation here where parts come in, go to the incoming bucket, go to inspection, outgoing bucket, drawer, dispatch for the simulation. Now I can edit the parameters of the task, so things like duration or giving the task a name. inspect fixture positioning. I'm going to go ahead and put in a duration of 32.3 seconds using our metrics and things that we've collected from shop time studies. And then I can also go ahead and I'm going to specify that this is actually a 6-part process. We take 6 in, load them up, run the inspection, we take all 6 off, unload. So I can specify that, I can click OK, and now effectively at this point I have set all of the logic for this simulation. But there's a few extra pieces we might want to take advantage of. What about scrap? We're doing an inspection process here, so there are going to be parts that fail. Well, we have a scrap bin. I added a new flow pattern that goes to that, and I can have scrap parts moving through that and then dispatching from the manufacturing flow. So we're saying, is this particular path or this particular arrow taking good parts or taking bad parts? So I'm able to route parts based on that. This means that you can do rework. This means that you can do scrap dispatch from the simulation, get an exact idea of, over the course of a shift, how many parts are we losing. Now it's all based on essentially an inspection pass-fail rate. So you'd have to have those numbers from quality for that. So let me get into assigning the resources. When it comes time to assign the resources and get this going, basically from here, this is where we tell workers or robots in this particular case what tasks they're doing. So I'm saying that my worker is going to go ahead and move parts from the drawer system to the machines. And then there's actually going to be a multi-pallet system here. So while the robot is feeding one machine, the machine is going to be essentially, while the machine is machining, the robot is going to be loading the other side. So we're able to kind of keep that simultaneous action going, and we can ensure that the robot is always running. We're going to be able to see metrics at the end as to how much time the robot is spending idle. So now, just kind of taking a look at a couple final items in this, we want to make sure that we have a robot assigned to some of the activities, like, for instance, the drawer system changeover. The robot is going to be essentially tied down every time we burn through, I think it was 64 parts in this particular one. Looks like a little bit more. But essentially, every so often, the robot is going to be stuck for about 29 seconds as it does that drawer changeover. So what does that mean? Our machine's going to be sitting idle when that happens. And now I can run this, and over time I can see exactly whether or not that machine is ever idle by looking at its processing output versus waiting for waiting for output, waiting for input, different things like that. So we're getting, what I like to say is we're getting data that matters. We're seeing how the production flow actually shapes out. We can put numbers to it, and we can then help our executives make better decisions around equipment purchases and that type of thing. This is our way to essentially eliminate some of the Joe thinks this, Jay thinks that you see on the shop floor, where someone has an idea for where to put a piece of equipment, someone else disagrees, has a different idea. Well, now you can test those ideas out ahead of time. You could see which idea is actually better, and then you can make those educated decisions. And I pointed out earlier that what I see a lot as I'm talking to companies is they're not making changes to production very often, which makes sense, right? You don't want to make changes to what is already working if you don't know that what you're going to do is better. This is a way to fix that. This is how you could start to see, is this new equipment purchase actually going to be, if it's actually going to provide that return on our initial investment. So let's just kind of circle it back here and actually watch the simulation run. So this is where it starts to feel a little bit like a video game. You get to kind of watch the worker run around a little bit, feel like I'm playing The Sims, and I get to see parts move through the simulation. I can see that there is consistently 6 parts on this inspection station. There's not a lot of idle time there. And if I wanted to, at any time, I can expand out any of the sections here to see these charts with additional information. So I can see that this is spending a fair amount of time waiting for input. A fair amount of time, there's no parts ready to come in. And it's also spending a fair amount of time waiting for output. So waiting for a resource, which means the worker is busy doing something else while the machine is done inspecting the parts. So I can keep track of all of that at a very granular level every step of the way. And you can also track things like your fail rates, how many parts have gone out of the simulation for failures, different things like that. This allows us to essentially take takt time and get real metrics relative to that takt time. Now, this particular simulation example ran for about 4 minutes because it was a real-time simulation. We've also run simulations that have gone for months. You set up a scenario, you set up the logic, you could set up shift schedules. You can get really intense with it, really granular, and you can even introduce randomization so that you can run the same simulation under different circumstances 50 different times and understand the full range of data. Once that simulation runs, we get all of our data in a report. And I can open up that report. In this case, I'm viewing it inside of Lean Team Player, which is like a smart whiteboard kind of thing. Really good for this type of document review because it allows you to kind of mark up the stuff that matters, mark up the specific problems, and you can quickly take stuff and turn it into actual actionable tasks. This ties in with the platform's task management system. So these items that I'm creating here actually will generate tasks for the assigned people. So it can be kind of nice for that. In this case here, I'm looking at a few different things. We have high idle times on some of the machines, and we're starting to kind of see some things really ballooning out. So we had a note here that one of the machines was waiting a lot. It was constantly waiting for a resource. So I can go ahead, I can define actions and things like that that we could potentially take. So one of the things we're considering is offloading fixture prep to station 3. And I can go ahead and create that as an action, and I can assign it to someone, in this case myself, and it's going to create a task in my task system for me. And I can continue to do that for all of the other results. Now, a couple things I just want to point out. There's so much information here on the screen. I'll point out the ones that I tend to find people are using the most. Of course, you could see all of your cycle times, the averages there. Another one that I've seen some people find particularly interesting is you can see the total distance traveled by a worker over the course of a shift. Am I making this person run 50,000 steps in a day where they're probably going to be a little bit tired, maybe not as fast anymore? Or is it manageable? I could see the idle time that everybody has, so I can start to understand how much time in a day does this person have? Am I expecting them to go at full speed 100% all day long? No breaks? You could start to test those things out and really kind of understand exactly what you have. As well as that, while the system is entirely no code, which I think is something that's very important to mention, you can set all of this up without writing any code or anything like that. A lot of times when you want to do this type of simulation, you have to start writing code in order to do it. The system is entirely no code, but it does have the flexibility where you could start writing custom, essentially, code to go even further. We've seen that done in a couple cases for scenarios like onboarding a new employee. I can set it so that the employee takes 60 seconds to do this task, but after 1,000 runs, they take 55 seconds, and after 10,000 runs, maybe they're down to 40 seconds. So I could apply logic like that and test out scenarios. I can test out essentially the rollout of a new cell over the course of 6 months. So a lot of different things going on here that we can ultimately take a look at. So just kind of summarize here what Virtual Factory is. That's really the whole goal here is if you're coming into this and you've heard the term Virtual Factory, but you don't really know what that means or what that looks like, now we've kind of seen that Virtual Factory is split into the two pieces, the plant layout, which matches up well with Virtual Factory Standard, And then the simulation side, which is matched up with Virtual Factory Professional. I'll share one more quick story that I think is just an example of where this really comes into play and where it proves to be, in my opinion, most beneficial. We had a project with a client. They had two pretty major projects going on. They wanted to revamp one of their robotic cells. They wanted to revamp one of their machining cells. On their machining cell, it was a robot-tended machining cell. They were going to significantly reduce the cycle time. They had changed up the way they were machining the parts and doing some things. They were going to significantly reduce the machining time. They were worried that once they did that, the robot would no longer be able to keep up. They knew how fast they were able to, in their robot programming tool, test out the fastest scenario, essentially figure out how fast the robot could possibly go. So we had the fastest case numbers. We put those in. We ran simulations. And ultimately, in that particular case, we weren't even close to falling behind. The robot was great. But they already had quotes in for a bigger robot because they just weren't sure. They had no idea. And it's a really, really hard thing to do with the drawer changeover was really kind of the main thing that was throwing off their numbers, making it hard to tell, is with that robot sitting idle every 29 seconds, was it going to start to fall behind? That was kind of the main thing. So they were essentially about to make a very large purchase on a guess. We were able to put numbers to that. They saved that money, and it ended up coming in handy because as we started taking a look at the other cell, we saw a lot of problems and we saw a lot of opportunity for improvement. They had a robotic cell. They were essentially creating a direct clone of that robotic cell, mirror image of it, and they wanted to have one person running two robotic cells. So that person would have essentially just been responsible for loading the machines, but then also assembling different components as they came in. We ended up having them come into our office for a workshop. It was 2 whole days where I had put together some simulations, and we essentially just had 8 people from their team watch the simulations run and ask questions. And what we started to see was something really, really, really stinking awesome. They started looking at the simulation, and they started asking questions about problems we weren't trying to solve. They were worried about whether or not the operator was going to be able to keep the robots loaded. But almost none of the questions they were asking were about the robot loading. They were all about the assembly step that the operator was doing at the front end. Because that was where the simulation had a lot of idle time. They were essentially assembling one assembly at a time, setting it on the table, waiting for the machine. They had a riveter that was going, waiting for that to finish, and then loading that back in. They were going one part at a time, and then they were just waiting. Well, so we ended up making significant changes. We added a queuing station so that they could assemble as many as they wanted, let them pile up as they have the free time in between robot loads while the robot's running, and they were able to make some changes. And ultimately, initially we tested out essentially we were able to keep the robots running about 30% of the time. After making all of those changes, we were able to keep the robots running with the same one worker 100% of the time. So we saw a significant improvement there. So the thing that's, I think, most powerful about this is it's the visual aspect. You're not just looking at data. You're not just looking at Excel spreadsheets. You can actually see it run. You can watch it in real time, or you can watch it at 64x speed. And you can then ask the questions that are important, and you can test out those scenarios. You can also set up 10 to 15 different scenarios, add them to a queue, and just hit run. And it will run all 15 scenarios. You walk away for a little bit, grab some coffee, come back, and you've got your numbers that you can now sit down and look over. So the whole idea with Virtual Factory is really, we want to be able to make educated decisions about our operations. In a lot of cases with CAD, it's a little bit simpler than that. There's a little bit more room to experiment. But when we're moving massive machines and things like that, there's just not that level of flexibility. So this tool allows us to get the data that matters and make decisions that will actually have an impact. That's kind of the idea. And that's really what I have here to talk about today, but I'm here to answer any questions that you might have. I'm happy to talk about other projects that we've done with clients. I'm happy to talk about projects that you're thinking about that you're wondering if this is maybe something that could help out with it. So I'll be here hanging around in the room. I'll answer some questions here that you guys got. And yeah.
That's something integrated on this tool to make an AR or VR analysis to put the customer in the field to, you know what I mean?
Yes. So there is an AR and a VR module. I don't have all the specifics on it, but I can get them for you. I bel- I know some of the AR VR tools are available in this version, but I don't know to what extent. You might be able to get just so far, and then there's other tools that are more focused on the AI stuff. But I'll circle. If you wanted to stop up here, I can get your contact info, and I can send you what I find out for you. Yeah.
But that's for the more VR. But is it possible to mix it with reality? You know?
Yes. So you're talking like the difference between like a Quest headset that's fully over your face, you're fully immersed, versus something like the glasses where you wear it, it's projected onto the glasses, you could still see the real world. Apple Vision, I guess, would be the big one. So as far as the specific hardware, the specific devices, I don't have all the details, but what I can say is Dassault has a partnership with Apple to work with them on Apple Vision Pro for a variety of different things. So I would imagine that whether that is out today or something that will be integrated over time, it is almost certainly something that will exist. But I'll circle back and I'll let you know what I find out on that.
Which kind of license do I need to get each one of the simulations that you first need?
Yeah, so to get the kind of okay, so the question was which version of the product or which license do I need to be able to do the simulations that I showed up here? So to do the simulations that I showed up here, what you would be looking at is Virtual Factory Professional. So essentially, if you ask for Virtual Factory Professional, that's going to include both the plant layout capabilities and the simulation capabilities.
Is that exclusively through 3D experience, or are you able to get just like desktop?
It's a good question. It is dependent on the 3D experience capability to save data to the cloud. It is leveraging that cloud data management as the data management backend for this. Right now, there's no way to fully disconnect it. You can, realistically, once you install the tool, you could run it in offline mode and work locally through importing and exporting. I probably wouldn't recommend it though. The data management is really when you get to factory layouts, the data management connection is really one of the things that matters so much because you could start to classify all that equipment for reuse later on. So we have a client that just finished, they used this for a new plant. They were part of a huge merger. All of a sudden they had 6 new facilities that they had to design layouts for. So that team was under a lot of pressure and a lot of stress. And they used this to create the layout of one of those 6 facilities as part of their initial pilot. And they just finished going live with that facility. So they just shared that with us a couple weeks ago. Now they're looking at doing some factory optimization and simulation for their existing main facility that they have. So, but in their case, tying back to your question, the reason I bring that up is that was hugely beneficial for them because now that they're getting ready to go into that next stage, they have created a very comprehensive library with all of their machines, all their equipment, all broken out. So as she's been working on that next simulation, she's essentially just been pulling from there. So that's really nice.
I work with robotics with Delta robotics. Does it connect in any way? It's totally
Yes, yes. What I'll say to that, definitely get my contact because I have a presentation I did last year on how the two work together. I co-presented with someone from Dassault, and we showed that connection. And if you have both solutions, we try to emphasize with people, you don't need to have both, but if you have both, it's really stinking cool. Because in that particular case, I created the layout, I sent it over to Mariah, she then created the robot cell layout. Now, when I was doing it, I didn't care about reachability of the robot or any of that. I didn't know any of the kinematics of the robot. So when she took my layout, she just opened my layout up in Robot Programmer, moved some things around to make sure that the robot could reach everything, and then just let me know that she was done, she had saved it, I opened it up on my end, and now I had her updated layout with all of my factory flow stuff already put in because I had done it before. So her moving stuff around just updated for me on my end. And then we went back and forth quite a bit on that. It was actually really, really, really cool. Yeah.
Can we have different products, like different routes, imagine of different paths, and imagine if you have availability in one machine and the process fits, can fit it with the right product to manage availability of machines.
Yes.
Products, because many customers don't just manufacture one product. Sometimes a machine it's for a lot of products, or sometimes every product is different.
Yeah, you're exactly right. And that's so each of the different flow paths in that simulation, you can specify essentially from there what types of products can move through that flow. So I can have multiple different branching paths that come off of there. This one only takes this product or that type of thing. And then you can also set ratios or schedules. So a ratio would be 50% of the parts move through this flow, 50% move through this, or 30-70. Or you can do a schedule where part A, part A, part A, part B, part B, part B, part C, part A, part A, part A, and it will just loop. So you can kind of do that as well. So there's a lot of stuff you can do with this you can get really granular with it in terms of shift schedules and that type of thing as well.
Do like a dynamic, kind of like padding and stuff for the workers. Basically, because we make really big stuff, so it's like this will get stored like on the factory floor somewhere. So as we do that, the travel and idle time would increase because people are moving around or picking it up with the crane. Like that stops work because everyone has to clear out the bay. That sort of stuff.
That's a really interesting question. I do not know the answer to that. Everything I've done has been with dynamic pre-generated pathing because essentially what you do to get, actually, no, I do know the answer to that. Yes, you can. It's done a little bit differently than how I typically work with the tool, but you can do it. Essentially you can set up walk routes or hallways or corridors. I don't know exactly what they call it. But you set up these predefined paths and workers will work along them, and you can set up traffic intersections, things like that. So if it's a forklift moving through in a walk path, you could set it so that workers will always stop and wait for forklifts or the other way around, that type of thing. So you can do that, although it depends on what you're trying to do with the simulation, I guess I would say. So it's kind of a little bit situational. In a lot of cases, the simulations I'm trying to do more automatic generated collision free walk paths where I put all my equipment in and I just pick a starting point, end point, and it figures out where the worker's gonna go. So you can kind of do it either way there. All right. Well, if anybody wants to take down contact information or talk about anything, let me know. I'm happy to help out. Otherwise, thank you guys so much for coming. And everybody that's going a distance, safe travels back in getting where you got to go.